Hello, my name's Peter Loader from PL Insights. Welcome to this presentation titled The COVID Pandemic, How Many Excess Deaths Were There? The presentation contains analysis of weekly registered deaths data sourced from the Office of National Statistics. Its purpose is to estimate the difference between the number of deaths that we would have expected to occur during and after the pandemic and those that actually did. At the time of the analysis, weekly death data was available from the ONS up until the 22nd of May 2023, a long time since the end of the pandemic, which for the purposes of this presentation, I will define as the end of 2021. We shall see from the presentation that, firstly, there are still significant numbers of excess deaths occurring. We'll also see that there are different methods for calculating excess deaths, and that these different methods give very different answers, and in my view, also vary in how sensible they are to use. Compared to the method used in this presentation, some of these methods, which are used by government departments, firstly overestimate the amount of excess deaths that occurred during the pandemic, and secondly underestimate the amount of excess deaths still occurring. That latter point is of particular concern to me, as it could reduce the effort put into getting to the root cause of those deaths and doing something about it. The presentation is structured as follows. Firstly, some introductory slides explain why I put the presentation together. Secondly, I'll detail the data sources that have been used to underpin the analysis that you'll see. Before looking at understanding the variance between expected deaths and actual deaths, it's useful to understand something about any trends in the number of deaths that have been occurring, for which we'll look at the 10-year period prior to the pandemic. After looking at the variance, I'll then draw some conclusions from the analysis. My name is Peter Loader. I've been applying business analytics and predictive modelling software for over 30 years now. The knowledge and experience that I've gained in doing that enables my company, PL Insights, to deliver what I call insights with acumen. So using data that can be extracted from operational systems and by talking to practitioners within the business, I undertake analysis, draw conclusions from that analysis, and provide information to senior executives within organisations to help them make better, more informed business decisions. So why did I put this presentation together? Well, I noticed what appeared to me to be an increased prevalence of medical emergencies occurring at football matches since the COVID pandemic. I've watched a lot of football, both live and through television, and I can barely recall any such emergencies. And yet I can distinctly remember one occasion, for which I provide a link within the presentation, where two medical emergencies occurred at different football matches in the crowd on the same day, both within the Premier League. So I wanted to see whether there was anything behind that. Is there indeed increased death rates since the pandemic? Secondly, I wanted to test out the knowledge and experience I'd gained that I'd predominantly applied in the emergency services and see whether those techniques could be applied on new data sets that are in the public domain. And thirdly, I needed some material for my new company's website, so this is going to form a blog post. Before we progress, just a bit of a disclaimer. I'm not providing any warranty on the accuracy of the data, nor my analysis of it. I imagine that much government policy has been formed on far flimsier evidence than what you'll hopefully see in this presentation, but I wouldn't want anybody to go about making decisions on the basis of this presentation. It's just been put together for a bit of fun, which probably means I'm a bit of a sad data geek. Moving on to where the data came from. So most of the data came from the Office of National Statistics, ONS website, which contains weekly data on the number of deaths that have occurred in England and Wales. And we can go back as far as 2010 with that data. You'll see later on that I've also made reference to census data from 2011 and 2021 to enable me to look at whether the number of deaths occurring is aligned to any changes in population. The weekly deaths data gives me a number of fields. Unfortunately, the format did change during the 10 years leading up to the pandemic, so I've had to simplify the more recent analysis more than I'd have liked to enable me to use that older data. However, we've got a number of age bands, so people under 1 1 to 14, 15 to 44, etc. up to the 85 plus age band. So I've got the number of deaths occurring in each of those age bands, and I can break that down by male and female. We've also got data on the regions that people died in, England and Wales being counted as 2 regions, but England split into further regions. And we can see how many deaths have historically occurred from respiratory diseases. There was a change to the classification of those again partway through the data set, which appears to make a slight difference to the volumes, but nothing significant in terms of what we're looking to do with that data. We can also see deaths from COVID, for which there weren't any before the week ending 31st of January 2020. And there is a differentiation partway through between those where deaths were actually caused by COVID as opposed to where COVID was mentioned on the death certificate. Unfortunately, that wasn't available throughout the whole data set. That differentiation, come back to that. Whilst age and gender can be combined, I can't combine all the other fields together, so we're a bit limited on combining some of those parameters. Interestingly, the ONS itself uses a 5-year average to predict future death rates. So it takes the equivalent week in the previous 5 years, looks at the average number of deaths in those 5 particular weeks of the 1 week per year, takes the average of those and compares that to the number of deaths that have occurred in the most recent year, the difference being either a positive or a minus number of excess deaths. A few terms that I'm going to use in the presentation. So the first one is what I've called the baseline period. So that covers the 10 years from January 2010 up to the end of December 2019, giving me 521 weeks of data over the 10 years. That's because there's 52 weeks in a year plus, well, on average 1¼ days extra, because we have 365 days most years, at 366 in a leap year. So that enables that baseline period will enable us to understand what's happening in terms of volumes of deaths by age, etc. over that period. In the data, each week has got a week number, normally 1 to 52, but in 2015 and 2020 there's actually a week 53 in those. And note also that some weeks will straddle year ends. It's useful to use the week number because that convention enables us to pick the same week from previous years to do that average calculation that I just referred to. But it does mean that some weeks will straddle a year. So for example, the week ending 27th of December 2019, the following week has got 4 days in 2019 and 3 days in 2020. It will count as a 2020 week in my analysis. The COVID period for the pandemic, I've started that from the 28th of December 2019, so it effectively gives me 2 years worth of data, albeit the first COVID death wasn't recorded until the week ending the 31st of January 2020. Again, for the convenience, it's useful to consider calendar years and do comparisons on a yearly basis. And then the post-COVID period is anything that happened from the 1st of January 2022 up till the end of the data that I've got, which is 26th of May 2023. Hopefully that gives you an insight into the data that we're using for the analysis. Now let's have a look at what it tells us about the number of deaths occurring in the 10 years leading up to the pandemic. So the first chart, on the vertical axis we can see the annual number of deaths, and we've got year going along the bottom, ranging from 2010 up to 2019. So what we can see is the shape of the blue line and the number of deaths in each year looks like it's on a rising trend, and if we fit a straight line to that using a technique called regression, then we can indeed see that that is a rising trend, and on average there are 5,924 additional deaths per annum compared to the start point over that 10-year period, which is about 1.2% increase per annum based on 2010. It's worth thinking about what that means, because if we use a method for predicting next year's deaths based on the average of the last 5 years, then our forecast is always likely to be lower than the actual number of deaths experienced. So there's a bit of a weakness in that method that the ONS is using, given that we've got that rising trend. It's also worth noting, however, that there's quite a bit of variability. It doesn't follow a perfect straight line. 2015 seems to be a year where we had a lot of deaths, whereas 2019, for example, falls below the trend line. And we'll explore this a little bit later on in the presentation. We could, if we do actually just look at the last 5 years before the pandemic, actually it looks like that's a fairly flat period. If we drew a line through those 5 points, we'd get a horizontal line pretty much. In fact, I'll do that later on, which is interesting because that arguably would suggest that the 5-year average is a good method. But if we were to use that to project forward, how would we explain the step change from the previous 5 years to those 5? My view is that changes in population and what have you are more likely to have influenced that increasing trend, and that clearly is something that's more likely to be happening on a gradual basis. This next chart looks at the number of deaths that have occurred in each week of each year in the 10-year period. So on the vertical axis, we've got the number of deaths, again in each week. On the horizontal axis, we've got the week number, ranging from 1 to 52, and a couple of weeks where we've got 1 week actually where we've got a week 53. As you remember, that was in 2015. The colour coding indicates which year we're talking about. It's not particularly important to be able to look at each individual year from the conclusions I'm drawing here, but the lighter the colour, the more recent the year. So for example, that year there I think is 2018, where it looks like we had a peak around weeks 10 to 12, which is sort of March time. So you can see a number of things from this chart. The red line is the average across the 10 years, and we can see that average is higher in the winter months. So at the back end of the year, weeks sort of 48 onwards, and then at the beginning of the year, perhaps weeks 1 to 12, whereas in the middle of the year, during the summer months, that's when the number of deaths reported are at their lowest. One exception to that is Christmas. It seems that deaths that occur during the Christmas week tend not to be recorded until after the Christmas period, which is why deaths always drop during that week, and correspondingly we get a bit of a rise in the first week after Christmas. It's also noticeable that during the summer things are pretty consistent year on year, whereas in the winter we have some years that are have a high number of deaths and others are much lower death. There's a lot more variability in the early months of the year, and some years the peak occurs a lot later than in January. This slide shows us the average weekly deaths by gender and age over the 10-year baseline period, 2010 to 2019. It's colour-coded blue for boys and pink for girls. We've got the age bands up on the vertical axis, and the horizontal axis is the number of deaths per week. So what can we see? Well, we can see first of all that females over 85 is the age and gender combination that has the most deaths per week on average. In all of the other age bands, there are more male deaths than females. That's I think generally recognised. I think males are a bit more reckless in their younger ages, hence we see a far greater number of deaths than for females. Starts to even out when we get to the 65 to 74 and 75 to 84 age range. In general, there are an increasing number of deaths in each age band as we get older, the exception being males in the 85 plus age range, slightly fewer than there are in the 75 to 84 age range. This chart reproduces the trend analysis that we did for deaths in total, split down by age band, lumping males and females together. I did look at the male and female difference, but they're pretty similar in terms of the trends. So the colour coding is on the right. We've got number of deaths on average per week on the vertical axis, and the year going along the horizontal axis. So if we take the yellow as an example, so the colour coding is the age band, yellow is the 85 plus age band, you can see there's a rising volume of deaths on average per week in each of the years of our data set. and again you get that similar fluctuation that we saw in the total deaths. For the 75 to 84, there's a very slight rising trend. Similarly for the 65 to 74, a bit more of a rising trend there. And you can see I've worked out what the growth rates are per annum. So in the age ranges 45 and above, they're all rising, only 0.2% per annum, 45 to 64, 1.6% for 65 to 74, 0.4% for 75 to 84, and 2.2% for the 85 plus. There's a falling trend in deaths for the under 45s. For those that are in under 1, there's a 2.2% fewer deaths each year, 1.7 fewer for the 1 to 14, and 0.5% per annum for the 15 to 44. Those percentages I've just taken as a percentage of the 2010 reported deaths for each age band. So this is where the census data comes in. I was a bit concerned to see that we'd got rising volumes of deaths in some of the age bands, and thinking, what's causing that? Is there some disease that's affecting these people that's causing more of them to die? Or alternatively, is it due to perhaps a change in the population? So I've looked at the census data from 2011 and compared the population by gender and age band from 2011 to what the 2021 census tells us. Now, appreciate it's not exactly the same period, but it's nevertheless a 10-year period, and 8 of the years cover the same period, so one imagines the trends are going to be pretty similar across those two periods. So the left-hand table tells us by male and female for each age band what has the change been in terms of the number of people in England and Wales in those population groups. So for example, I can see that males over 85, there's been a 33% increase in the number of males in the UK in that age band, whereas for females it's only 7.6%. So overall, we can see the population's increased by 6.3%, rising from 56 million to almost 60 million, and the compound rate is about a 0.6% increase per annum over that period. That 85 plus males is the group with the largest percentage increase. The right hand side here is the annual change that equates to. So that 6.3% overall is equal to a growth of 0.6% per annum. So why is that important? Well, actually, the growth rate or otherwise that we saw in overall deaths is pretty well aligned to the overall population group. So we were getting around 2% 85 plus. Well, there's been a 1.5% increase in the number of population who are aged over 85. Similarly, the 75 to 84, 2% on the 65 to 74. So it's not unreasonable to have expected an increase in the number of deaths in those age groups year on year based on just the change of population. So I think it's reasonable to say that the driver of that rising trend in numbers of deaths is caused by a change in both the volume of population overall, but also the age mix. Clearly, we would expect higher mortality rates within the older age groups than in the younger ones. So we've understood a bit about the makeup of deaths that occur year on year prior to the pandemic, and also the trends that we've seen in terms of a rising number of deaths each year that we need to take into account if we're going to compare the observed number of deaths with what we would have expected to happen. So let's start getting into the variance from the baseline. Again, before we look at predicted deaths and the difference, how many actual deaths were there caused by COVID? So this chart has got one recording for each week. So we've got the number of deaths per week on the vertical axis, weeks and the date of those weeks shown on the horizontal axis. I think the labels are for every 4 weeks. And the chart starts from the beginning of 2020, 1st of January 2020, and runs through to the 26th of May 2023. The orange line is the number of deaths recorded where COVID was mentioned on the death certificate. From 2021, there was a differentiation in that the ONS started to also record deaths that were due to COVID, as opposed to ones where there was just a mention of that on the death certificate. So what can we see? Well, those of you who are familiar with that period might remember that the first peak occurred during April 2020, just around here. It peaked at around 8,331 in the week ending 13th of April, and the second peak occurred on the 25th of January 2021 when we had 8,433 deaths where COVID was mentioned on the certificate in that week. So those were the 2 peaks. You can see deaths when COVID actually dropped down significantly in the summer of that first year. But if we look at beyond the second peak, there is still some ongoing deaths recorded. And in fact, there are in January 2022 and 2023, there are some small peaks in deaths that we'd expect to see from that type of illness during winters. What's the difference between the blue and the orange line? Well, from when the orange line when the blue line started to be recorded, about 80%, just under 80% of all deaths that involved COVID, about 80% of them were actually due to COVID rather than it just being mentioned on the death certificate. It's also worth noting, as I say, there are some ongoing deaths. In total, there were 204,526 deaths where COVID was mentioned over the entirety of that data set, of which 160,543 were in the calendar years 2020 and 2021. So this slide goes back to an earlier slide from the presentation where we saw the trend in overall deaths from 2010 to 2019. So I've reproduced those 10 years worth of data here, and the trend line, the dark grey line, is the trend line that we saw previously. The difference now being that I've shown the deaths that occurred in 2020, 21 and 22 on that chart. What we can see is that there are clearly a lot more deaths occurring than we would have expected had we continued along the grey trend line. And if we look at the difference between 614,114 and what we'd have expected according to the trend, there's an excess of 67,625. In 2021, there are 33,486, and interestingly, we've still got 18,558 extra deaths occurring in 2022, even though I think most people would agree the pandemic itself had ended by 2022. So in total, over the 3 years, we've got 119,669 excess deaths using that method, of which 101,111 were in the 2 pandemic years, 2020 and 2021. The ONS, of course, would have used a slightly different estimate of the number of deaths occurring in 2020 and 2021. And I've actually plotted that as a red line here. So if we had taken the 5-year average from 2015 to 19, then you can see that the gap from 614,000 to the red line is more than the gap to my 10-year trend line, as a result of which they would have projected 81,478 excess deaths in 2020 compared to my 67,625. Excuse me. Similarly, 53,000 in 2021, 44,000 in 2022. So that means they've got a total of 179,001 excess deaths over the 3 years compared to my 119,000, and 134,741 excess deaths compared to my 101,000 in the pandemic period. So you can see those two methods do produce different results. My method suggests there were actually fewer excess deaths during the pandemic than the ONS was reporting as the deaths progressed real time. So, which method is correct? We've seen that the 5-year average method produces a significantly different answer in terms of expected number of deaths compared to using the longer term trend method. I'm not necessarily sure that we can say one is definitely better than the other and that one is right and one is wrong. However, I think it's fair to point out some of the disadvantages of the method using the 5-year average. In particular, it infers that 2019 onwards, we'd expect to see the same number of deaths as we've seen on average in the last 5 years, and inherently doesn't explain, well, what caused us to go up from around sort of 495,000 deaths per year to the 533,000 that we see in that 5-year period. We know from the census data that the population is on a rising trend and is aging. I don't think that happened in a sudden, with a sudden switch being pressed in 2015. I think that's something that's been gradually happening over that 10-year period. So I'm not sure that I would run with the 5-year method. The 10-year trend appears to be more robust. We've seen that the rising number of deaths matches reasonably closely the changes in population once we take into account overall growth and the changes with individual age bands, i.e. the aging of the population. I do accept that how you handle 2010 and 19, which are a little bit outliers, 2010 high, 2019 perhaps a bit lower than the norm, will affect the slope, but I think it's a more robust method than the just taking an average of the last 5 years, which, as we discussed previously, where we have got a rising trend, that is always going to produce an underestimate of the next year's deaths. It's not just me saying that there's a problem with the 5-year average. Both the ONS and something called the Office for Health Improvement and Disparities also recognise the problem by definition, because they're now looking to use other methods to measure predicted deaths and compare those with the actual deaths occurring. So the ONS has applied something called age standardised mortality rates, ASMRs. You can go on their website and find out all about those if you wish, but my understanding is that they try to take into account expected changes in age of the population. The ONS also publishes a modified 5-year average for its weekly excess deaths comparison. In 2022, it's used 2016 to 19 and 2021, so it's discarded the 2015 deaths. For 2023, it's discarded 2015 and 16 and is using the period 2017 to 19 and 2021 to 2022. I've not looked into the OHID method, but I can quote the ONS, which says that the OHID measure looks at the trend seen between 2015 and 19, well actually there wasn't much of a trend, as well as accounting for population, deprivation and ethnicity. So what do we make of those revised methods? Well, I think that 2019 death trend already accounts for any change in population size and demographic makeup, because that's what resulted in the number of deaths that have occurred in those years and how that trend has developed. Unless we think there's a major change to population makeup since then, I don't see why we wouldn't want to just continue a projection of that trend line that we've seen. In terms of the OHID, I wouldn't build any new deprivation ethnicity measures because I think we can just see that those trends are already being reflected in death rates. Regarding the ONS modified 5-year average, well, that seems a bit flawed and potentially misleading to me because we've already seen that 2021 and 22 had excess deaths in them. Therefore, if we incorporate that into our projection, we are going to assume that excess deaths are going to continue in the future, when actually we're trying to calculate the excess deaths. So that doesn't really seem to make sense to me. Again, it comes back to, I think, really that 10-year trend. They may be better forecasting methods than sticking a straight line through it that I've done, but the correlation measure is pretty strong, and I think it's a good starting point, and certainly better than either of the two proposed alternatives there. So now I want to spend a little bit of time drilling into the detail of what happened week on week in each of the pandemic years, 2020 and 2021, and then the post-pandemic period, 2022 and 2023 year to date. So you remember you've seen a chart like this before. We've got the weekly number of deaths, the volume of those on the vertical axis, week number of the year on the horizontal axis from 1 to 52, and occasionally week 53. The coloured lines represent each year of the data set. If you remember, 2010 through 2019, with the lighter coloured blues being the more recent years. And I've now overlaid 2020 on top of that. So we can see much of the year deaths are in line with the norm up until the pandemic starting at the end of January, and indeed up to pretty much week 13, so we're getting to around the end of March, before we start to see a noticeable rise in deaths, peaking in April as we saw, and then tailing off. The summer is pretty normal. You almost not notice any difference, but it starts to kick in again as we get into the autumn and winter approaches, with higher numbers of deaths being recorded from week 42. It's worth noting as well that that peak of 22,000 there is about 10,000 more than the peak we've ever reached in that sort of period of time in any of the previous years. You might remember the peak was only around 8,000 deaths where COVID was mentioned. So just interesting to know, why did we get 10,000? Was it because deaths were occurring where COVID wasn't recorded as a cause of death at that time? If we look at 2021, you recall the peak was in January, and so we can see in terms of excess deaths, that is indeed when they appear to peak. That's when there's the greatest gap between anything we've ever seen before in terms of weekly deaths. But then things seem to return to normal after the first 9 weeks or so, for quite a period of time. But from about week 27, so we're looking at sort of July time, we're starting to see an excess number of deaths occurring, despite the fact that I think around June 2021 was when the vast majority of people had their initial vaccinations. In 2022, we're now into the post-pandemic period, and we'd probably say at the start, for the first 17 weeks, a little bit, it's probably above average compared to the 10 years of our baseline, but certainly nothing out of the ordinary during the winter months. However, once we get to week 17, you can see that the orange line is now consistently above the expected number of deaths. And if you remember, in the summer, it's pretty predictable how many deaths we're going to get. There's a very tight, narrow band of variance between 2010 and 2019, and generally it is purely that population growth and aging leading to more deaths in that period. So I think we can just visually see that there's clearly excess deaths ongoing from week 17 onwards in that data. So 2023 year to date, clearly we only have observations for the first 21 weeks here, and as we commented previously, the number of deaths in each of those weeks is quite volatile. Had we not seen the 2022 performance over the latter half of that year, I think we might have been tempted to say, well, it looks like we're experiencing a pretty bad year, but it's not beyond the realms of the possible. However, we've only ever had more deaths in 7 of those 21 weeks in a previous year, and of those 7, 3 of those 7, it was only in 1 year that we ever had more deaths than have been recorded. So my inclination is to say that actually it looks like those excess deaths are continuing in 2023, and it's going to be interesting to see what happens through the summer into autumn as to whether we see the same picture as in 2022, i.e. a continuing orange line well above the historical blue lines that we've seen in previous years. For completeness, we can have a look at what's happened to the trend in deaths by age band. So this chart, I've zoomed in a little bit on the scale here because the volume of deaths in the under 1s and 1 to 14s are much lower than some of the other age bands. So you'll see I've adjusted the range on the axis for each of these charts so that we can see what's going on within each of those individual age bands. So we've got numbers of deaths by week on average for each year, with the year going across the bottom. So we can see that the under 1s is the blue band. There was a falling trend up to 2019, and actually I think we'd probably argue that the numbers of deaths, certainly no evidence of a significant number of excess deaths in the 3 years of the pandemic plus the post-pandemic 2022. And similarly for the 1 to 14 age range, again we've got slightly fewer deaths 2020 and 2021, slightly higher in 2022, but nothing I would say that's statistically significant at this stage. Clearly, if both those 3 observations that we've got above the line continued for another couple of years, we might start to worry, but nothing conclusive there to worry us. If we look at the 15 to 44 age group, we can see that from 2010 to 19 we're on a slightly falling trend. However, when we get to the pandemic period and indeed the post-pandemic period, we get an increased number of deaths well above that falling trend line. It's interesting that 2021 and 2022 have more excess deaths rather than 2020, which was the first year of the pandemic. So certainly some questions to raise, particularly around 2022, as to why that is. The red line is the 45 to 64 age range, pretty much a flat trend in 2010 to 19, as we saw before. Here we can see there are considerable excess deaths occurring compared to that trend line in 2020, 2021, where it peaks, starting to fall off again in 2022, but still markedly above where the trend line would suggest we ought to be. The 65 to 74 age range was on a reasonably significant rising trend. Nevertheless, we can see that 2020 and 2021 both got a considerable number of excess deaths. However, that does seem to have recovered itself by 2022, where we're very slightly below the expected number of deaths according to that trend line. And finally, the green line shows the 75 to 84 age range. So that was on a very slightly rising trend. We can see that excess deaths appear to peak in 2020, but there are still a significant number of excess deaths in 21 and 22, considerably further above the line than we've ever been in any of the previous years. The 85 plus is a little bit more interesting. So we get a large number of excess deaths in 2020, but 2021 and 2022 slightly below the trend line. Now, of course, that could be because we had such a significant number of excess deaths in 2020 that it has materially affected the population there, and that is the reasons why we're not seeing as many deaths in 2021 and 2022. So, what conclusions can we draw from our analysis of the difference between expected deaths and observed deaths in the pandemic 2020 to 2021 and the post-pandemic period of 2022 and 2023 year to date? The first one is that the method that we use to estimate expected deaths has a significant impact on our calculation of excess deaths during those periods. If we apply my 10-year method to the pandemic period, then I calculate that there were 101,111 excess deaths, whereas the 5-year average method favoured by the ONS at the time calculated 134,741 excess deaths, a significant difference. As a side note, the ONS reported 134,380 between March and December of that period, so 22 months. It reported that in its December 2021 bulletin. That very much ties in with that 134,741 number for the 24 months as a whole. I think we can be certain that under both of those methods, there were excess deaths occurring in 2020, 2021 and 2022. Given that's the case, it seems very strange to me that the ONS should incorporate 2021 into its 2022 method and 2021 and 2022 into its calculation of expected deaths for 2023. That appears flawed because we are saying that the expected deaths in those years has already got an allowance of excess deaths built into its calculation. So not only does that appear flawed, it's potentially misleading because it means that the predicted number of deaths in those years is going to be higher than it should have been, which means that the excess deaths calculations for those 2 years will be underestimated, all other things being equal. Its December 2022 bulletin also has an interesting conclusion because the ONS concludes that mortality rates observed in England and Wales in 2022 were lower than would have been expected as calculated by the Age standardized mortality rate method. That surprises me because just a visual inspection of the data that we've seen shows that clearly for the vast majority of 2022 we were running with a significantly higher death rate or number of deaths than we would have expected based upon the previous 10 years. And in the first 16 weeks, I don't think there's anything unexpected about the number of deaths that occurred in the first 16 weeks of 2022, as I say, week 17 onwards, running at an excess. And we know that week 17 onwards are the entirely predictable part of the year, i.e. the summer and the autumn. So I haven't looked at the detail of the ASMR method. You can do so on the ONS website. There is a link that explains it. I don't have the detailed data to enable me to reproduce it, but if that's the conclusion they're drawing, I would raise some question marks about the validity of that method. There are some anomalies on patterns of excess deaths in the different age ranges, so the same conclusions are not reached in each age range. So for example, the under 1s and 1 to 14, there's no evidence of any change in the volume of deaths over and above what we would have expected in the pandemic and post-pandemic periods. However, the 15 to 44 and 45 to 64 age ranges had some excess deaths in 2020, but they peaked in 2021, and there's a further significant ongoing excess during 2022. The 65 to 74 age range peaked in 2020 and 2021, but now appears to have returned to the number of deaths we'd have expected to have seen in 2022. 75 to 84 and 85 plus both peaked in terms of the volume of excess deaths in 2020. However, whereas the 85 plus band has returned to its expected levels of deaths by 2021, and that's continued in 2022, the 75 to 84 band has retained a significant excess volume of deaths in 2021 and 2022. So overall, the calculation based on the 10-year trend does suggest fewer excess deaths during the pandemic and the ONS method. But of more concern to me is the significant number of excess deaths still being reported, which to me is surprising given the investment that we made in the vaccinations programme. And I think it's important that that number of excess deaths is flagged up, and in particular is not masked by the revised methodology that the ONS appears to be using, which, if you use that methodology, you appear to conclude that mortality rates are in line with what's expected. That conclusion is vastly different from what my 10-year trend method would suggest. And indeed, even if you use the ONS's alternative 5-year average based method, we are still running at excess deaths well above what we'd expect. I think there is some recognition that there are some ongoing issues, because I note that more detailed data on cause of death has become available. I'm guessing some people will have access to that over a long historical period, and we could repeat the sort of methodology that I've applied here to that data to help us better understand what are the causes of those excess deaths that we're experiencing. Just going back to one of my reasons for creating this presentation, which was my observation of sports events where spectators at those events seem to be having an increased prevalence of medical issues during those events. Given that the 15-64 age range, I would have thought, would be a good proportion of the sports event attendees, then actually it reassures me that this has been worthwhile, because it seems that my observation that triggered this analysis that I've done did have some merit. Finally, thank you for watching this presentation. I hope you found it interesting. I would like to state that I've got no political agenda in putting together this analysis. All I've tried to do is apply my skill set and experience to a data set that's in the public domain and a little bit different to the data I've been analysing over the last 20 years or so. If you are watching this as a potential client of PL Insights, then I've hopefully given you a flavour of the outputs that insights with acumen might yield. In particular, the way in which the analysis is presented is key to getting the message across such that it's acted on, and how interpreting the analysis will impact on the conclusions drawn and therefore the decisions that you might make on the back of it. We saw here how two different methods of calculating excess deaths led to widely different conclusions as to how many excess deaths there were, and indeed the potential to conclude that currently there are none at all. Being able to identify those differences and recommend which is the right approach is critical to getting the right conclusions out of this work. And therefore, hopefully you can see the value of adding acumen to insight. There are plenty of people who can run a query on data. There are fewer people who know which queries to run on which data, and even fewer people who can then apply that acumen to getting the right conclusions from the analysis. As a client said to me recently, we've seen all that data before, but no one has presented it to us like this before. Thank you for watching.